Jan, I leave the stage. I leave it to you.
Okay.
Thank you.
Hello, everyone. Thank you for having me. Yeah. Okay. Now, hello, everyone. Thank you for having me. I am a type designer in urgent need of a new tool. And at the same time, I want to urgently divest myself from the macOS platform, to which I'm currently bound because the industry-leading font editor is Mac only. And I have promised myself as soon as things go south significantly, I will start developing a new font editor. And here we are. I'm creeped out by the developments of these operating systems, and I want to switch to Linux. So Counterpunch is the name of the new font editor. The Counterpunch is the tool you see here on the left. It's a tool from the metal type era when the the counters, which are the inside shapes of letters such as the inside circle of the O, got punched into the punch, the actual punch here on the right. And the connotation with the boxing move of the same name is a pure coincidence. I'll start the whole talk backwards. I'll start with the credits. In making a new font edit from scratch, I acknowledge that I'm standing on the shoulder of giants, in particular Babel font, Simon Cousin's font source format conversion tool, which I'm using to read fonts. And to write fonts, and it comes with an API in Rust that I'm not using. I'm just using it to deserialize fonts, source fonts into JSON, and then using that. Also, the app is based on HarfBuzz, which most people probably know. I would call it industry-leading shaping engine, as well as FontC, Google's new font compiler. That the whole idea is based on to make a font editor in the browser that compiles fonts in real time. And YJS, a data live collaboration exchange protocol used by Figma and Google Docs, amongst others, as well as all previous font editors. I'm going to do a quick rundown of slides here and then show you the real editor. So everything runs in a browser window. There's a Rust component with Babel font that I'm using to open files. Also, I'm inferring it to give me interpolations of glyphs. And it's also subsetting fonts to a smaller version of itself for compilation in the browser. But it's subsetting at the source. Typically, it's done in the binary file. Simon implemented that at the source level in Babel font, and then FontC, obviously part of Rust. And then the part that I'm implementing is like down here, the actual editor in JavaScript, and then also HarfBuzz.js in JavaScript used for shaping and rendering. And then a second, like you can open several browser windows and work on the same font in several windows. YJS is used as a data exchange format here, where everything is happening autonomously, except for the except it's not reading source files. That's crossed out here. So it's just, and I'm using that because at some point in the future, I want to offer cloud hosting and live collaboration. So I'm building on YJS from the beginning, even though strictly it's not necessary to just talk, two browser windows talk to each other. But I'm using YJS from the beginning to weed out errors so that in the future it can, work seamlessly once actual cloud collaboration. So there's a quick life cycle of a font. It gets read from the user file system. So this only works with browsers that actually offer access to the file system. Chrome/Chromium is the preferred browser here. Other Chrome clones, such as Brave, for example, which is my daily driver, do not use the file system API or whatever it's called. So Babel font reads the file. The main editor is implemented in JavaScript, so the object model lives in JavaScript. Asks for interpolations, and then when a font gets rendered on screen, it gets compiled and rendered. First, it gets subsetted by Babel font, then handed over to font C in Rust, compiled, and then coming back into JavaScript for shaping and rendering. Today, the compilation speed in the browser, as I mentioned, works because of subsetting at the source. So all of these lines here, this is maybe not the best infographic. It's a bit of a like what I kind of envision is like mechanical parts that where like I work only on the kerning, and then only the kerning gets pushed to Rust, and then only the kerning gets subsetted and then compiled, or only glyphs, or only OpenType features certain kinds. In the future, what I want to achieve is I want to have font C stay in memory and keep like basically build a full increment, what I call incremental compilation, where all of font C stays in memory and only recompiles one glyph, or only recompiles the kerning OpenType feature, or only recompiles whichever part is currently being edited, with the entire rest of the font staying in memory, and therefore compilation being ultra fast, even faster than it is now. I may even want to attempt to make a permanent fork of font C for that purpose, if the authors are not interested in incremental compilation, but I haven't asked yet. I have yet to ask, so this is undetermined. So the browser itself, sorry, the app itself is free and open source, free to use without user account forever, but there's a proprietary component, and currently I envision this becoming a commercial company that generates its own income with a Python script generator. I'll touch on that in a second. And then future cloud hosting. There's a subscription that's currently open for business already. And I use a purchase power parity adjusted monthly subscription price. So you can pay between 2 and 12 euros a month, roughly ballparking, depending on where in the world you live and work. Okay, now I'll switch to the actual app. Here's the website. There's a button that opens the editor. There's a font here that's preloaded that you can double click and use and play around. So one of the novelties of this editor is as I mentioned, the live compilation of fonts. So if I move that anchor here and that dot down there moves, that's a live recompilation of the font in the background, and only of those letters that you can see here. So that's the subset. One of the reasons I made this editor is because typically font development follows this tedious edit, compile, test cycle. So you edit a font, you need to compile it. Sometimes it takes a lot of time, and you need to load it externally into like an app, whatever graphic design app that you're using to test the font, and then you need to go back. And this is like an official complete font that you see here. So it kind of completely removes that whole cycle. You can play with variable fonts. There's also an animator here. You can turn OpenType features on and off. You can type. There's a not def visible at first because it's recompiling, subsetting and recompiling in the background. And yeah, you can turn OpenType features on and off as if you were in a application. I really need to race through this. There's plugins. These are Python plugins, pure Python plugins that get loaded through the. Oh, I completely forgot to mention the whole Python component. So there's a Pyodide component here that allows me to, because like Pyodide offers JavaScript, basically pass-through access to JavaScript everything. So it's Python scripting in a type design application is very important ever since I think type design applications had APIs. I think they were implemented in Python because the Python maker's brother, Just von Rossum, is a type designer and a teacher in The Hague. And I think through that connection, they scripting APIs have more or less always been in Python, to my knowledge. I'm a bit younger than these guys, so I don't have all the memory. It's a pure Python plugin. It gets loaded through the Python plugin interface. So you can through micropip here in Pyodide, you can sideload other Python modules, and then they would immediately show up. Here's a scripting window where you can write Python scripts, and I'll jump. Like, I'm a bit all over the place and very chaotic. Sorry for that. Oh shit. Okay, I need to re-enable folder access. Okay, filters. So here's the glyph overview. There are all these filter lists here. These are also Python plugins, pure Python plugins, and they're implemented in code. Typically in font editors, glyph filters are like point and click interfaces where you can say, like, I want to see glyphs with components or only glyphs with outlines or whatever. One of the novelties here are glyph filters that are implemented in code. And they have these subgroups, and you can click on them and, like, you know, click on a glyph and then see which groups it belongs to and so on. And the real fun is here. You can make a new filter, and it's a Python script. And then you can open that in the script editor. And this just returns all glyphs. It's just a function that gets the font object, and then in this case, because it's the example, it just yields all glyphs. So how do we make that accessible to users who are not so technical? Because the app is aimed at professional users and novices alike. Since the idea of these being code-driven filters is that you can access any data point in the font that you would like. And so it's more flexible than traditional point-and-click glyph filters. But how do we make that accessible? We use the built-in chat, the AI assistant. This AI assistant only generates Python scripts. It's not a full agentic tool calling AI assistant. Many people in the font world are very skeptical of LLMs and AI and everything, and in many cases for good reasons. So this is a lightweight assistant that only generates Python scripts, so it doesn't send any data anywhere. It just asks for a Python script and executes everything locally. So it's just generating an algorithm, and a reusable algorithm, because you can save it and reuse it later on. So show all glyphs with a top anchor. And then once the result returns, it should automatically reload the filter. Yeah. So all of these glyphs have a top anchor. Top anchors are these little guys here that you can use to, like, move components around. What else? Yeah, there's also another context here that I call font context. This is all in development. This is all super alpha. This is working on the font object itself, so this is not generating a filter. Visualize. This is the example I always type: the vertical distribution of top anchors in the font. Sorry that that's taking so long. It's a bit of a downer. I should do like streaming responses so that you can, or I will implement streaming that you can see response streaming back to you as it's being generated. There we go. So this is a matplotlib graph that was generated in real time. So here you can see the vertical distribution of all your top anchors. And then you can open this in the console here, look up, like study the code, save it, reuse it for later. And both, like all of these scripts that are being generated are algorithms. So you can reuse them. You don't need to constantly burn tokens. Like a chat here burns like 8,000 tokens on average compared to hundreds of thousands of tokens that an agentic chat session will burn. However, also the intelligence of this system is very limited. So you can't go like, my OpenType features aren't working. Why? Why is that? Because the AI does not currently have access to that. So people have already asked me to implement like a full agentic tool calling assistant. And ultimately I will end up doing it. But I do think that this is the more intelligent approach to max out, because it's so much faster and so much more efficient and so much more private. Type designers, being artists, have, for understandable reasons, much objection to their data being sent to Anthropic or OpenAI or God knows who. And so I think this is actually a very intelligent approach. And I do want to max out the intelligence in the editor itself, meaning like to add more functions that can do certain stuff. It won't be design related because the designer is supposed to sit in front of the computer, but I want to try to put as much intelligence into the object model, basically as convenience functions that then the assistant can call just by its name, because LLMs are really good at compressing a prompt into just like one tool name that then gets executed on the font object locally. Another thing I may want to point out, this is now getting very nerdy, and if you're not into font development, this will bore you, but OpenType features are not exactly easy to develop in some cases. There's this thing here. Sorry, that was my presentation. This thing. This is the HarfBuzz chart of which writing system uses which OpenType features in which order. So here on the left, you have index systems, then Arabic and Syriac, Khmer, Myanmar, Universal Shaping Engine. So if you want to debug issues in your OpenType features, you have to typically know what's happening here. And so far, font editors have not been displaying or have not been helping font development with regards to the running order of these OpenType features, and Counterpunch does. It breaks down, the order of the list here is broken down into these parts. So there's a default shaper, and in this case, because it's an Arabic font, it also has, you can choose an Arabic shaper, and then the running order of those features here changes. Only the ones in the middle you can actually sort. These are user sortable. They're called discretionary features. These are like ligatures and stuff that is not critical for the script. The critical features, you can't sort them. They're in a defined order, and that order is not defined by me. It is just being displayed. And then there's a second section down here where it says used by Arabic shaper continued. Those features run after the user definable section, and so that helps a lot in debugging what's happening here. Also, you can search for glyphs, and then it will filter basically the glyphs to all those where the glyph is actually participating in OpenType features. So you can like very much shrink the scope of what you're looking at. I have a minute left. Just a word about all the Python modules. So there will be several places here. There's, for example, there's no place yet to add new glyphs, and people typically use language definitions, but there's competing offerings. There's GF languages by Google Fonts. There's Hyperglot, and so I'm also envisioning that being implemented as a Python module that can get side-loaded. And the end game about the Python modules is that basically each company or team or whatever can compile a set of Python modules that basically represent their development environment. So like visualization plugins, language definition plugins, glyph filters, and then that can be linked in a font and side-loaded on open. Like as soon as you open a font, because it's a browser, it downloads everything. And basically your whole development environment will be available to you just by opening a font. And with that, I conclude my very brief, this is all alpha, and in a few weeks, I may be able to ship a workable first, like complete version. And then like by the end of the year, I'll try to be done with 1.0.
Thank you very much. Yeah, and can show your last slide, I think, for context
The last
reason.
slide, yes.
And we are going over to Q&A, and I already know that we have one question there. So I bring it to you.
Hi, thanks. You mentioned that it used YJS. I was just curious, is there collaboration thought into it?
I'm planning for live online collaboration. That's one of the most demanded features. There's no editor, to my knowledge, that offers it. So I'm using YJS now early on to just communicate between several browser windows in the same browser, just to weed out issues as early as possible. But I am absolutely aiming for live collaboration.
So I think you showed in the editing window multiple glyphs that I assume you can jump back and forth between to edit. Are there other edit views for things that show variation axes together or anything like that? Or does that make sense?
I'm not completely sure what you mean, but I'll show you quickly something I didn't show, which is the stack preview. This shows nested components. Oh, I completely forgot to show how you can just like double click into components and edit them in place. That was one of the most important innovations of this editor, instead of like the shaping being broken apart. And yeah, there's the stack preview where you can then like jump to a nesting level directly, navigate. And
I guess I was asking about that sort of view, but for variable axes, but it's kind of...
well, there's only the sliders here for now. I'm not completely sure what you mean. Tell me in private.
Okay.
Two more questions. Any more questions? Frank is one. Yeah.
What library do you use for overlap removal?
OpenType what?
For overlap removal, what
Overlap removal? None so far.
Okay.
Not implemented yet. Simon Cousins has suggested something to me the other day, and I forgot because I was too drowned in work. I haven't done it yet.
Okay, looks like we're out of questions. So thank you again very much.
Thank you.